Hello, my name is Magnus Petersen. This talk is about share buyback valuation under uncertainty. I will assume that you have already watched the first talk on share buyback valuation. So you will know that the value of a share buyback depends on future earnings, and future earnings are uncertain to some degree, and in mathematics we model uncertainty using stochastic variables. The value without a share buyback is a potential for dividend payouts. It is denoted small v and consists of the excess cash that can be paid out as dividends now, plus the present value of future earnings. The value after dividend taxation and per share is denoted capital V. The stochastic variable for v is denoted capital V with a sort of a double line, but I will just call this for the stochastic V. The value with a share buyback is denoted capital W, and it is given by this formula, which you find in the first talk on share buyback valuation. So this is a deterministic value with the share buyback, and the stochastic value is denoted capital W with double lines here, and I will just call it for stochastic W. And it is essentially the same formula. We are ignoring the dividend tax and the number of shares because it factors out in the calculations that we are interested in. So we just have the stochastic V minus buyback divided by so on and so forth. The mean value without a share buyback is denoted E of the stochastic V. If V is a discrete variable, then this is a formula for calculating the mean value. And if it is a continuous variable, then the formula is this integral here. The mean value with a share buyback is denoted E stochastic W, like so. And from the properties of the expectation operator, using the definition of the stochastic W from the previous slide, we find that this is the formula for the mean value with a share buyback. The mean equilibrium is where the mean value to eternal shareholders is unaffected by a share buyback. That is, the mean value with a share buyback equals the mean value without a share buyback. If we just insert the definitions from the previous slide and reduce, we get that the mean equilibrium is when the market cap equals the mean value without a share buyback. Usually we write it as an inequality so we can see when the mean value increases from a share buyback. The relative value of a share buyback is the value with the share buyback divided by the value without the share buyback. This is the formula for the deterministic value, and this is from the first talk on share buyback valuation. The stochastic version is denoted like so, and it is the same except we replace the deterministic V with the stochastic V. The mean relative value is a relative value averaged over all possible outcomes of V. So if V is a continuous variable, then this is the integral that we have to calculate, and it turns out to be this formula down here. And note that it is the mean of the reciprocal stochastic V, and this does not equal the reciprocal of the mean V. And we will get back to that. The relative equilibrium is where the mean relative value of a share buyback equals 1. And if we use a definition from the previous slide and reduce, we find out that the market cap must be equal to 1 divided by the mean of the reciprocal of the stochastic V. We usually write it as an inequality, so we can see when the mean relative value increases or when it is greater than 1, and the condition is that the market cap must be less than this number over here. But if the value to eternal shareholders must be ensured to increase from a share buyback, then the market cap must be below the minimum possible value for V. So the market cap must be less than the minimum value that the stochastic V can take on, and then the value with a share buyback is guaranteed to be greater than the value without a share buyback. Note that this is not an equilibrium, because we cannot have equality, and there's no by implication either. When the variance of the stochastic V is greater than 0, then we know from the so-called Jensen inequality that the following holds. This over here, the mean value of V is the so-called mean equilibrium. This over here is the relative equilibrium. So we know that the relative equilibrium is always smaller than the mean equilibrium. We also know that this value here, which is called the harmonic mean, it is also greater than the minimum possible value of V. So we know that the minimum value is less than the relative equilibrium, which is less than the mean equilibrium. This means that the mean and relative equilibriums cannot both be satisfied simultaneously. If the market cap equals the mean value of V, which is the mean equilibrium, then we know that the mean value with a share buyback equals the mean value without a share buyback, but then the mean relative value is less than 1. And it has to do with the nonlinearity of the relative value, so that potential losses are greater than gains. And again, you should see the first talk on share buyback valuation for more on this. The variance measures the spread of possible values, and a share buyback increases the variance of the value to eternal shareholders. So the variance of the value with a share buyback equals this number here, and this is just from the properties of calculating the variance, and this is greater than the variance of V. Let us consider an example of Acme Corporation. So assume the value without a share buyback can take on two different values. It can be $10 with probability 0.9 or 90%, or it can be $1,000 with probability 0.1, that is 10%. So the mean value with a share buyback just uses the formula for calculating the mean, and it is $10 multiplied by the probability of $10 plus $1,000 up here multiplied by the probability of $1,000, which is 0.1, and we get the mean value without a share buyback is $109. The mean equilibrium is where the mean value with and without a share buyback are equal, and we know from one of the previous slides that this is when the market cap is less than the mean value without a share buyback, which we just calculated to be $109. Now assume that the market cap is in the mean equilibrium, so the market cap equals the mean value without a share buyback, which is $109, and let's say we make a share buyback for $5. So if the value is actually $10, and this occurs with probability 0.9, then the relative value is calculated using the formula from the previous slide, and we just plug in all the numbers, and we get about 52%. So that means a loss of about 48% to the shareholders of Acme Corporation. If the value is instead $1,000, and this occurs with probability 0.1, then the relative value is 104%. So it's a 4% increase in the value to the shareholders of Acme Corporation. One way of calculating the mean relative value is first to calculate the mean reciprocal value, and it is calculated using this formula where we have to use the reciprocal values of V. So it is 1 divided by $10 multiplied by the probability of that, which is 0.9, and the same with 1 divided by $1,000, and what we end up with is 901 divided by $10,000. And then we can use this formula for the calculating the mean relative value, and we plug in all the numbers, $5 for the buyback and $109 for the market cap, and this mean reciprocal value that we just calculated, and what we get is about 58%. So on average, we would have a loss of 42% to the shareholders of Acme Corporation if we make the share buyback. The relative equilibrium ensures that the mean relative value is greater than 1. And it is a formula from before, and we calculated this number on the previous slide, and we plug it in, and we get $11.10. So if the market cap is less than $11.10, then the mean relative value is greater than 1. So let's assume that the market cap is $10.50, which is slightly less than the relative equilibrium. And let's again say that the buyback is $5. Then the mean relative value is calculated using the formula from one of the previous slides, and we plug in all the numbers and we get 105%. So on average, we would have a 5% increase in the value to eternal shareholders from this share buyback. However, the relative equilibrium is also insufficient. Let's consider the first case where the value V equals $10, and this occurs with probability 0.9. And let's plug in the numbers to calculate the relative value. We plug in the buyback amount of $5 and the value V of 10 and the market cap of 1050. And recall that this is slightly less than the mean relative equilibrium. And what we get is the relative value is 95%, which means a 5% loss to the shareholders of Acme Corporation. And recall that this occurs with 0.9 probability. So we have a 5% loss to shareholders with a very high probability, even though the market cap is less than the relative equilibrium. So the relative equilibrium is clearly insufficient in evaluating whether the share buyback increases value to eternal shareholders or not. The other case is when V is $1,000, and this occurs with probability 0.1. We use the same formula, plug in the numbers, and we get out 190%, which means a 90% increase in value to the shareholders of Acme Corporation. But this only occurs with probability 0.1. If we must be certain that the value increases from the share buyback, then the market cap must be less than the minimum possible value. And the minimum possible value is $10. So let's say the market cap is $9.50 and the buyback amount is again $5. And we plug in all the numbers in the formula for the relative value, and we get 106%, which means a 6% increase in the value to the shareholders of Acme Corporation. In the other case, where V is $1,000, this occurs with probability 0.1, then the relative value is 210%, which means a 110% increase in the value to the shareholders. So in both cases, we have an increase in the value to the shareholders. And this is when the market cap is less than the minimum possible value of V. There are a number of far-reaching implications from this theory. If a share price equals its expected value to eternal shareholders, then a share buyback would still increase the uncertainty of that value, and any potential losses from the share buyback would be relatively greater than any potential gains. What this means is that it is impossible for the dividend substitution hypothesis and the Modigliani and Miller dividend irrelevance hypothesis and the efficient market hypothesis to be correct. These are all incorrect. This is shown mathematically. So they're rubbish. Don't believe them. They have no use in finance. To summarize, the mean and relative equilibriums are for average outcomes. Both equilibriums cannot be satisfied simultaneously, and only share buybacks at a market cap below the minimum possible value ensure that shareholder value is increased. A share buyback increases the variance or the degree of uncertainty of the value to eternal shareholders. This talk was based on two papers, the short one, which is good for an introduction, and the long treatise, which is much more detailed and takes a long time to read. They are both available on this internet website, and the links are also provided below the video.